Hey there, Dango Stu here. In today's video we're going to be installing a regulator rectifier into a Yamaha 20 horsepower so that we can charge the battery from the motor. I'll go through a bit of the theory on the board before we install this, just so you know how it gets wired up. The wiring for this varies very slightly if it's an electric start motor or not. In this case it's a pull start motor that has a battery to run a bilge pump, which just gets taken ashore and charged periodically. So we don't have a starter motor, but it would be much more convenient to have a charge for the motor so it never has to be taken out of the boat. One really important thing the boat has to have is a lighting coil under the flywheel. This is a coil that as the magnets in the flywheel pass the coil, they induce an AC current in the coil. And that's what this regulator rectifier is going to convert to DC so we can charge the battery. On Yamahas, two green wires coming out from the flywheel basically tells you you've got one of these lighting coils installed already. This motor did, I didn't have to put it in, so I think it's pretty standard to have it, not necessarily to have this regulator though. In this case, those two green wires from the lighting coil go to a round plug on the lower cowling, so that AC current is sort of presented to the outside if you want to use that, but we're going to be disconnecting that when we install this regulator. So the regulator rectifier has a black wire, a red wire and two green wires. The two green wires are the AC in, and then the red and the black coming out are the DC out. So it's a really straightforward thing to install. As well as converting the AC to DC, which is the rectifier part of this, it also has a regulator to make sure that at high RPM you don't end up overcharging the battery, sending more than about 14 volts to the battery. So it actually sort of does two jobs in one. If this outboard did have a starter motor, you would be running the wires to the ground on the engine block and then also to where the battery came in to the solenoid. Now, all that really does is save you running some extra cabling. You're just using the existing battery leads. So I'll quickly draw that, but in this case, we're going to have to run all the way back to the battery. When you've got a starter motor in, all you really have is your thick battery leads come in. The negative is going to go to the engine block somewhere. Generally, it attaches somewhere like one of the mounting bolts for the starter motor, so you've got a very direct connection to the starter motor, so you get good current flow, low resistance. Then your positive is going to come from the battery to the starter solenoid, which is then going to feed on to your starter motor. So what you'll find is that this junction point here, where the battery positive comes straight to the input side of the starter solenoid, is a really common place to pick up and pull off the power that you need to run things, but also to send current back in from the regulator to charge the battery. The negative from the regulator can go anywhere on the engine block, but generally, where possible, just straight to one of these. So for example, although I haven't really drawn it here because it was on the other side, if my negative battery lead was coming to this mounting bolt of the starter motor, this would be the obvious place to sort of get the best earth you can. So that's more the setup, the starter motor. The original diagram's more what we're going to do in the boat today. Alright, we'll go over to the bench, we'll open this and I'll show you the plan. This regulator rectifier is for this 20 horsepower. I presume they go up in amperage a little bit for large motors. That's the part number for this one if you're looking for something similar. And got to say, they're pretty common, pretty interchangeable, even across brands and things, to be honest with you. There's nothing particularly special about them. So here's our twin green wires. Because this is an AC current that oscillates, there's no positive and negative. It really doesn't matter much which way these go round. Although notice one is green and one's green and white. So I'll have a look under the flywheel. But with AC currents like that, it just oscillates. This is our ground. So it's a short lead with a ring connector. So we're going to find a bolt on the engine block that we can put that directly to. So that'll be our kind of be nice and easy close. Then we need to go from that same bolt off to the negative. And I also need to take a positive off. This has two positives, one fused and one from before the fuse. The one I'm going to send to the battery is the unfused one here first. The one after the fuse can be used to power any sort of accessories that maybe you want to run directly from the regulator. But in this case, I'll just be leaving that one alone. We'll be running this one to the battery, this under the coil, and that to ground. So these two green wires here that come up from under the flywheel, they're from the lighting coil. So we'll disconnect those. And this lead here goes to a socket on the front. I'll show you that. This is the AC socket here on the front of the outboard. This is where those two wires went to originally. This is not commonly used at all, so I don't have any real qualms about disconnecting it. So we'll leave those two wires loose, and this is what we're going to hook our regulator up to. I'm just having a look here. Yeah, these are both marked plain green, so it doesn't really matter which way they go. We've got a few options for mounting it, but I think I'm going to mount it here. On this outboard you'll see there's some threaded sections here. I'm not actually sure off the top of my head without looking what's the standard mounting position, if there is one, but we've got plenty of vacant spots, so I think I'll just go in here. All the threaded holes in this bracket are a 6mm fine thread, I think it is. I am just going to put a little bit of Loctite on this thread. This will just stop it vibrating off and coming loose. The earth for the regulator rectifier, however, I'm just going to take to here. I think it's a good distance, you know, it stops the cord being too bunched up. And there's already a couple of earths going here. I think it's good to keep earths grouped, provided there's enough thread on the fastener holding them on. Eventually you may end up with just so many ring connectors under one fastener that it won't actually secure properly. But in this case I think we'll be fine. Alright, what it means now is we need to connect our power and our earth to the battery. So I'll show you what I've made up there. What I've made up here is just a lead with a twin core marine cable. On one end I've put two 8mm ring connectors on there, and they'll be going onto the battery. On the other end I've got a smaller ring connector that I'm going to put onto another fastener on the engine block, so it'll be our earth. And then on this end I've got a male bullet connector that's going to go in the female bullet connector on the regulator rectifier. This accessory connector now is completely encased, even though it's got a bare terminal, it's got a housing around it, a shroud around it. It's not going to let it touch an earth and ground. But having said that, I'll just have a look here. So it's got a fuse in it from the factory, which is a 10 amp fuse, but I'm just going to take that fuse out to be double sure that it's never short circuits anywhere. And then we'll tuck all this down in the cowling, and then we just need to find a neat way to run this out of the cowling to the battery. This outboard here has got a little rubber plate here, which I presume you take off if you put throttle and gear linkages in for forward controls. So I think I'm going to pop this out, and rather than removing it entirely, I think I might just drill a hole through it, push the cable through so it's a reasonably tight seal, and then pop it back in. Here's the cover plate out. It's got sort of two halves like this, so I'm just going to drill one out. Alright, so that's drilled out now. What I need to do now is pass the cable through the out opening, then I'll feed them through here, then push the rubber back in. I've just fed this cable under the carburetor over to the starboard side. When you're feeding cables like this, just have a good look at what linkages there are and how they move. You know, move the throttle to maximum, select gears, whatever, just to make sure it's not in a position that's going to interfere with any of those controls. So just fed it out through the hole, then I'll put it through the hole I drilled, just one at a time. Given this is rubberized, it stretches reasonably nicely. There we go. And then I'll push this back in. Alright, so I'll grab the battery, we'll hook this up, and then we'll test it. These terminals on this battery are 13mm spanner, which is pretty common. Now I'm just going to use this multimeter to get a baseline voltage that the battery has to start with. And it's coming out around about 12.6 volts, so not too bad. Now I'll just fire it up and we'll see how it goes with the regulator rectifier attached. So with the motor running, I was getting over 13 volts, and more to the point, as you rev the motor, you see that the voltage starts to climb. So although it won't give a huge charge at idle, once you're actually underway, that voltage will climb and you'll start putting some current back in this battery. So thanks for watching. Hope this video helps you if you're looking to charge a battery from your outboard. It might also help you if you're having some troubles with your regulator rectifier and you're looking to replace it. If you don't have a lighting coil under the flywheel, things get a little bit more complicated, it's true. You'll need something like that before you can do it. And it'll depend on the model of outboard whether one can be installed or not, and how easy it is and how expensive the part is. But it is pretty common to have an outboard that has these two AC wires coming out, so you'll just need to do a little bit of investigation to see where you're at and what you need to get to the point of having this battery charging. So that about wraps this up. I do have a couple of t-shirt photos waiting to print and go on the board, so if you've sent me one, don't panic, it's in the pipeline. If you want to buy one of the t-shirts, the link to the online stores in each of the newer videos. But I also get a few questions about prices and shipping and everything. So the story is they're printed online when you make an order. They're printed in the US, so they're sent from the US to whatever country you're in. So if you're in Australia, for example, they can actually take a while to come back into the country. Also, the prices listed are in Australian dollars, so if you're paying in US dollars, it'll be less than the price you see. That's actually Australian dollars, and the currency conversion will affect that as well. So they're just a few finer points that people sort of often ask about. All right, well, take care. Thanks again for watching, and I'll catch you next week. See ya. Bye.